We will start our problem with a rectangle. Then inside the rectangle we will inscribe two identical regular hexagons which are touching on the one side, as you can see on the sketch. Now we will connect the midpoints of all 6 sides of our hexagon, and in this way we will construct this really nice star shape, or if you like a mathematical term, it would be a concave dodecagon. We will do the same for the other hexagon. And let's say that those two dodecagons have the area of 3. Now, the question is, can we somehow calculate the area of the difference between two hexagons and our rectangle? This awesome problem was sent to me by my subscriber Amira from Jakarta. Amira sent me this a couple of months ago, and she made me promise that I will implement her problem into the video. And I like to keep my promises. But also, she asked if it's possible to solve this without too much calculation. And actually the answer is yes. Of course, you guys can pause the video right now, try this problem out for yourself. There are multiple ways to solve this, and then come back and you can check my solution. Alright, so let's solve this problem together. So, as I said, I'm going to use the least amount of calculations possible, and in order to achieve that, I'm going to use the power of symmetry. So first, let's take a look at one of our hexagons. And just as a reminder, let's keep the area of our dodecagon on the right. Alright, so now let's enlarge our image. And let's pull the lines of construction of our dodecagon, and those are the lines that connect all the midpoints of our hexagon. Now let's also pull all 3 major diagonals of our regular hexagon. And since this is a regular hexagon, it will be divided into those 24 identical equilateral triangles. Now, let's take a look at the area of our dodecagon, or our star, if you will. This area consists out of 12 of those triangles, and this is exactly 1/2 of the area of the entire hexagon. So we can say that the area of the hexagon will be equal to 2 times the area of the star, which means that the area of our hexagon will be equal to 6. So now, let's again use an interesting property of a hexagon. If we divide any regular hexagon by using its big diagonals, we will divide it into 6 identical equilateral triangles. This is important because this means that one of those triangles has the area of 1, since the whole hexagon has the area of 6. Now, let's go back to our previous sketch. Here we will again divide our hexagons by using their diagonals as we did before. But this time we will not stop here. We will keep on dividing our figure. First we will extend 2 touching sides of our hexagon to the border lines of our rectangle, as you can see on the sketch. We will do the same for horizontal sides, and we will do the same for 2 remaining sides. Then we're also going to extend 2 remaining diagonals, and in this way we will have our rectangle divided into exactly 18 identical equilateral triangles, all with the area of 1. You can also see that on the borders of our rectangle we have some right-angled triangles, and those triangles actually represent the half of those big equilateral triangles, so their area must be equal to 1/2. And as you can notice, we have 6 of those half triangles. But remember, we have to find the area of difference between our rectangle and our 2 hexagons, and this area consists out of 6 equilateral triangles with the area 1 and 6 of those triangles with the area of 1/2. So we can calculate this and get that this is 6 plus 3, which means that the area of difference between our rectangle and two hexagons is equal to 9, and this is our solution. Now you can notice some interesting facts, that this area is actually equal to 3 times the area of our star. And if you want, you can calculate the area of the entire rectangle, and this area will be equal to 21, which is actually 7 times the area of our star. And how cool is that? So, I hope you guys enjoyed this really relaxing geometrical problem. And if you did, do not hesitate to leave a like or subscribe to the channel for more content. Of course, if you found another way, more, let's say, mathematical way to solve this problem, you can write it down in the comment section below, as you always do. And until next time, see you all and take care.